My people, I hope you are doing great. We got some additional practice going here. Good old dilations. So this is the fourth of our transformations. So now we know all of them. It's pretty exciting. Anyway, we're on pages 49 and 50 in our packet, I believe. We're going to do some dilating here. As you figured out, really not that bad, guys. Take the ordered pair, multiply it by that scale factor. That'll give us our new points, and that's exactly what we're going to do here on number one. So it says draw the image of triangle ABC after we dilated from the origin with a scale factor of 1/4. So first thing I got to do is literally come up with those ordered pairs there, right? So point A, all the way over here, looks like we're counting by ones, -6, -7, so that's at -8, 8. -8, 8. Okay. B, that's at the origin. That's a tough one there. 0, 0. And point C all the way down here at -8, -8. Okay. Multiply each coordinates by what, guys? Well, that's our scale factor. In this problem, that would be 1/4. Okay. I'm going to put A prime and all of them over here just because that way you can see both of them. And then we'll graph it. I'm literally just multiplying the coordinates by 1/4. That's all we're going to do. So -8 times the fourth, that's -2. Right? 8 times the fourth is 2. Same thing happens here. We multiply both of those coordinates by 1/4. It still turns into 0. And -8 is my last point, so we're going to multiply both of those by 1/4. That gives us -2, comma -2. Go ahead and plot your new points. So here's B prime. -2, 2. Here is A prime. -2, -2 is what? C prime. There you go. There is my new figure. Okay? There you go. That's, again, remember, guys, these points go down there. Good to go. Oops. Okay, what else can they make us figure out here? Now they're not going to give us a graph on the next two. That's fine because we're just going to multiply, okay, the ordered pairs by that scale factor. So it tells us here's a triangle. We're going to dilate from the origin. Here you go, scale factor of 1/3. What are the coordinates of S prime? So S is at 6, 3. And if we're going to use a scale factor of 1/3, we're going to figure out that, hey, S prime is at 6 times a third. 6 times a third is 2. And 3 times a third, that's 1. So there you go. So there's your ordered pair for S prime. It's at 2, 1. It's that easy. Rectangle, again, gives us all of those ordered pairs for the different vertices. Okay, this one's a little bit different. I take it back. It says, what is the length of segment Q prime U prime? Okay, so we know it's going to get dilated with a scale factor of 5. We have to figure out the new segment length. Well, here's what we're going to do. We got to figure out what the original segment length is. And then whatever, like if it's 3 or 4 or 5 or 6, however long it is, we multiply it by the scale factor, 5, and that's how big our new length, segment length will be. So it's talking about Q prime and U prime. So I need to pay attention to Q and U. I'm just going to use this graph down here. I think they should fit on there. I don't really know. So guys, Q is at 4, 5. 4, 5, right here. Okay. U is at 4, 10. So 4, 10, right here. So this is segment QU. Okay. How long is segment QU? Well, 1, 2, 3, 4. It's 5 units long. So now we can figure out Q prime, U prime. We're going to multiply by that scale factor, right? Multiply by the scale factor of 5. So that means Q prime, U prime is going to be 5 times as long as QU. So 25 units long. There you go. Okay. Here we are on question 4. Let's switch over there. All right. Is this an enlargement or a reduction? So again, the original figure is the red one. Okay. So there's the red one. The new figure is the blue one. So did it get bigger? Did it get smaller? Well, it got larger. So we would say that's an enlargement. I'll just say because it got larger, not smaller. Reduction would be getting smaller. Find the scale factor. Well, what do we know about an enlargement when we think of a scale factor? So is that a number bigger than 1 or between 0 and 1? Well, it's bigger than 1. Okay? Scale factor equals new divided by old. That's how I remember it. Okay? So what is the new figure? Again, we could look at a point. We can look at a side length. I think sometimes side lengths are easier to look at. So let's find the scale factor. I would like to know the side length right here from, what is that, J prime, K prime, and then I'm going to compare that to just JK. Just kidding. Okay? Well, JK goes from the origin to 12. Okay? So that's 12 units long. How long is J prime to K prime? Well, J prime, K prime, all the way to 50, so that's 15. Okay? Now, this is not a scale factor, 15/12. You either need to divide that and say, hey, this has a scale factor. Let's see, what is the biggest number we can divide out of those? I'm thinking 3. So we divide a 3, that would be what, 5/4? So you could say 5/4, or you could say 1.25. Okay, either of those works for me. And that's what you have to do. So scale factor, there it is. All right, draw the image. After we dilate from the origin with a scale factor of 3. That means everybody's going to get 3 times longer. So points, again, point P is right there at the origin. We multiply that by a scale factor of 3. That means P prime, guess what? Still at the origin. Q, is it -2, 0? Again, multiply by your scale factor of 3. Q prime is at -2 times 3 and 0 times 3. Last point is R, and R is at 0, 2. Again, multiply by that scale factor of 3 to figure out R prime. 0 times 3, 0. 2 times 3, 6. Okay, now we just got to plot our points, draw our triangle. So point P, still right here at the origin. Point Q, now it's at -6, 0. Q prime, here's P prime. R prime, all the way up here at 6. Okay, there's my new triangle, right? It is 3 times bigger. All right. And then there's always some tricky questions. So here we go. So we have to be a good reader. Not all graphs count by ones. You guys know this, but sometimes we see questions like this and we just fly by. So find the scale factor. I need to take new divided by old. So the new triangle is the image. That is the red one. Okay? The old triangle is the blue one. That's the one that's the pre-image that came first. Okay? Some people might say image divided by pre-image. That's fine too. Okay? Let's just do side lengths here. Okay? Be careful. When we're looking at our graph along the x-axis, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're just counting by ones. Okay? So what is this side length here? P prime to R prime. So 1, 2, 3, 4, 5, 6, 7, 8. This has a side length of 9. Okay? We need to look at the same side length right here in the blue triangle. So I need to look at this side length right here. So what is that one? 1, 2, that's 3 squares long. So 9/3. There you go. We get a scale factor of 3. Great. Could we have used these side lengths here? Absolutely, we could have. Right? Problem in doing that, guys, look, we're counting by 2s. And even more so, they're starting in the middle of a square. So that's, again, not a big deal. We can still figure out how long they are. Find the area of each triangle. We could do that. I don't really want to. Guys, we just need to know what these two lengths are, right? Area of a triangle, 1/2 base times height. Okay, but I can tell you right now, if there's a scale factor of 3 between these triangles, what's 3 squared, right? Area is in squared units. So 3 squared means, what is that, 9? That means the area of this triangle will be 9 times larger, okay, than the other triangle. Okay? And now we get this one here. Photographer uses a computer program to reduce a photograph, if I can talk. It gives us the coordinates. There they are over there. Draw the image after we dilate from the origin with a scale factor of 2/3. Okay? So here we go. So P was at the origin. P prime is still going to be at the origin. H was at 9, 0. Again, we're going to multiply by the scale factor of 2/3 to figure out H prime. So 9 times 2/3 is 6. Okay? So there's 2 of my new points. We can go ahead and plot those. Here's P prime. H prime is at 6, 0. That would be right here. H prime. Okay? O is at 9, 6. O, 9, 6. Again, multiplied by 2/3. Okay? Let's see. That's going to be 6. 6 times 2/3 is 4. Okay? So O prime is at 6, 4. And then we need to come up with T. T is at 0, 6. Again, multiplied by 2/3. All right, this is going to be at 0, 4, I believe. So 0, 4. Right? And that's T prime. Bam. There it is right there. Okay? How does the length of side PH? Well, guys, what's the side length on PH? Side length of PH. That's from the origin all the way out here. No, that's not 8. That's really 9. So 9. How does that compare to the side length of P prime and H prime? Well, P prime, H prime, right here. That's only 6. 9 divided by 6. You could say this is 3/2, or you could say it's 1.5. So that means this side, PH, is 1.5 times longer than P prime, H prime. That makes sense. This is the longer side, right? By what factor? By 1.5. Or 3/2. I think, 1.5 probably makes more sense to us. Just because it does. So anyway, so there you go. So guys, that's our additional practice. You guys should be dangerous enough now for our Math Excel and for our book work as well. So keep doing a great job. See you later.